Welcome to everyone in today's video lecture session on arithmetic, logic instructions, and programming 8051 microcontroller. Myself, Manoj Kumar Padai. The newly joined e-learners are requested to go through my previous video lecture sessions on 8051 microcontroller to easily understand today's video lecture sessions. The links are provided on the screen. So upon completion of the course, you will be able to write the assembly level language program using arithmetic and the logic instructions. So this is the outline of my discussion. First of all, the assembly level language programming with the instruction, means with the different arithmetic instruction like addition, subtraction, multiplication, and the division operation will be discussed, followed by the logic instruction like AND, OR, exclusive OR operation will be discussed, followed by the logical instructions for bit manipulation, and the compare and the jump instructions will be discussed. And finally, the programming with the rotate instruction will be demonstrated. Let us consider the addition operation which is performed by the 8051 microcontroller. So it is under the category of the arithmetic instructions. As you know that the source operand can be any register, can be any immediate data or any value that is stored inside the memory, but destination should be your register, which is nothing but your accumulator. Here in case of 8051 microcontroller, memory to memory, the arithmetic operation is not possible. So let us discuss with a good example. That is the RAM location 40 to 44 hex. These 5 consecutive locations are loaded with the value, different values. So write a program to find the sum of the values. At the end of the program, register A should contain the low byte and R7 will contain the high byte. So these 5 consecutive locations will be accessed by the programmer. Therefore, we shall choose a particular register which will indicate the particular memory point. After that, we shall increase the number by 1. Then it will indicate, it will point to the next memory locations one by one. Let us start with the instructions starting from move R0, 40 hex. Now 40 hex will be loaded inside the register R0. Now R0 is the memory pointer which is pointing the particular memory location inside the RAM, that is 40 hex. Okay, so it is from the sketchfile memory location of the RAM memory which is allocated for the programmer to write the program. After that, you say that R2 is loaded with the value 5 because I have to access 5 different consecutive memory locations. So the counter value is set as your 5 inside the register R2. Then I shall clear the accumulator. After that, accumulator is loaded inside the register R7. So both the register R7 and accumulator are cleared first before going to execute the instruction add a comma at the rate R0. So R0 means it is pointing the memory address R40, where from the data will be collected, and it will add with the accumulator, and finally the accumulator will contain the data. Means the final result will be stored inside the accumulator. Now I shall check whether the carry there is after the addition operation, if carry is generated or not. So depending on that decision whether the carry is generated or not, I shall jump my control to the next location, or I shall increment it. I shall increment the value which is stored inside the R7. Okay, so JNC means jump if no carry, then jump to the location next and you perform the operation. Means increment the value of R0 means so that it will point the next location for 1, and I shall decrement the value DJNZ R2 means R2 will be decremented by 1, and whether it is finding it is not equal, then it will jump to again to execute the instruction add a comma at the rate R0 means for 1 memory location will be accessed now, and then it will be added with the value which is inside the accumulator, and finally the result will be stored in the accumulator. Then it will repeat the process again. It will check whether it is generating a carry or not. Depending on that particular status of the carry, either it will jump to the next memory location, or it will execute the next instruction, that is increment R7. So if jump no carry, then it will jump to this location next. If carry is generated, then it will increment the value which is stored inside the register R7. After that, it will increment the register R0. Then it will check again the value which is stored inside the R2. So counter will be decremented by 1. So this process will be going on as long as the value inside the register R2 is not reaching to the value 0. Then whenever the R2 is equal to 0, then it will come out from this loop. So in the next example, besides how to handle the carry with the byte that is provided, which will be added with the value which is stored inside the accumulator. Okay, so the instructions, here is the instruction which will add 16-bit numbers. So during which the lower byte, whenever I'm just adding two lower bytes, it may generate one carry, and it will be added with the higher order bytes. Okay, so this is two bytes, two 16-bit numbers that is provided, and I have to add with the instruction. The syntax of the instruction is add CA, source byte. So what is the meaning of that instruction? The accumulator will be added with the byte which is provided with the instruction, and it will be added with the carry. Okay, so I have to check it. I have to check the instruction with a suitable example. You have to write a program to add two 16-bit numbers, place the sum inside the register R7 and R6, where the condition is that R6 should have the lower byte and the higher byte will be stored inside the register R7. First, you will see that I shall clear the carry bit, so CY will be equal to 0. After that, I shall write the instruction move A #0E7 hex, because that will be loaded inside the register, inside the accumulator. After that, I shall write the instruction add A with the immediate data 8D hex. So it will be added with the value 07 hex, and the result will be stored inside the accumulator. So accumulator is now transferred. The content of the accumulator is now transferred inside the R6, so that the lower byte will be transferred in the R6 register. After that, I shall check. I shall write the instruction move A, 3C hex. So 3C means this one, the higher byte will be loaded inside the accumulator. Then, if from the lower order byte, if any carry is generated, then I have to add it also. So therefore, I shall write, instead of add A, I shall write the instruction add CA, 3BX. So it will add the accumulator, the byte, and the carry. So it will the three on the same time, the accumulator, the byte, and the carry will be added, and it will generate. It will generate the result which will be stored inside the accumulator. Okay. So from the accumulator, I shall transfer the data to R7. So as per the instruction that is given inside the question. Now let us discuss about the subtraction of the unsigned number. So the subtraction operation is performed by most of the microprocessors using the sub instruction is should be. But here, in case of the 8051 microcontroller, there is no such sub instruction is present over there in the instruction set of 8051 microcontroller. Only we shall have to use sub B, means subtract with borrow. So how to manage this situation? Whenever any kind of borrow I have to subtract, then I shall use directly sub B instruction. Whether the borrow is not required, then I have to make initially the carry flag, which will be equal to 0 after, prior to the execution of the instruction sub B. Okay, so that it will be equivalent to your sub instruction. So now the carry flag will be used to handle the borrow, because there is no such the borrow flag is there, only the carry flag is there. So you have to use the carry flag to indicate that is the borrow one. To make the adder sequence, how the subtraction operation is performed whenever any kind of the sub B instruction is executed by the microprocessor. Actually, the circuitry which is associated with that function from the CPU, they will take the 2's complement of the subtrahend, means the source operand. After that, the addition operation will be performed with the minement, that is, which is stored inside the accumulator. Then the third process is that, third step is that you have to invert the carry. So look the carry, whether it is generating carry 1 or carry 0. So depending on that, the status of the carry, the result may be either positive or either it may be the negative one. Okay. So let us consider with the sub B instruction whenever the carry is equal to 1. So we are just taking this example, like clear C. First of all, I have to clear the carry, so that carry will be equal to 0. After that, we shall write the instruction move A, comma, hash 4CX. So load the value 4CX inside the accumulator. After that, sub B, A, comma, 6CX. So this 6CX will be subtracted from A and along with the carry. Now see that I shall check whether it is generating a carry or not. So jump if no carry, then jump to the location, means this location, and it will execute the instruction move R1, comma, A. Means accumulator will be transferred in the register R1. Otherwise, what it will do, that it will complement the accumulator and it will increment the accumulator by 1, so that we can generate the, or we can get the 2's complement of the number. So if it generates the carry, means if it generates the carry, then I have to complement it, so that means I have to increment the, means I have to, if carry is generated, then I have to take 1's complement, then I have to add it once to get the 2's complement, then I shall get the negative number. Okay, so let us take one example. Means we shall consider with this example, means we can explain it why in this way, that 4CX means this is the number 4, this is the number 6C. Now I shall take the 2's complement of this one, means 6C. So this one is 4C and this one is minus 6C. So it is represented in the 2's complement format. I shall add it because the microcontroller has this adder circuitry. So what we will perform, that it will add two numbers, means 4C minus of minus C, means actually it will be adding with the 2's complement format of 6C, then it will be added by the adder circuit. So actually it is performing the subtraction operation. So this is the number 4C, it is the 2's complement of number, and it is the negative 6C. After addition, you see that it will generate a carry. So I shall carry is equal to 0, means I shall have to invert the carry. So carry will be equal to 1. If carry is equal to 0, the result is positive. If carry is equal to 1, so the result is negative. Obviously, if we minus this one, if we subtract this one from 4C, it will generate a negative number. So negative number minus 2, it will be represented in 2's complement format. So invert it to get the original minus 2 as your result. So now the most important feature which is incorporated inside the 8051 microcontroller instruction set is that the multiplication and the division. So multiplication operation is directly performed by 8051 microcontroller, as it is not given, the provision is not given for the 8085 microprocessor. You have to go through the repeated addition process. But here we shall use the instruction mul AB, means the multiplication of the A and B. So multiplication of AB means the one of your operand is inside the accumulator and another operand is inside your register B. So register B is associated with this instruction mul AB, that is multiplication AB. Now where the result will be stored, the higher byte of the result will be stored inside the register B, and the lower byte of the result will be stored inside the accumulator. So result will be 16-bit byte, so that it will be divided into two registers in this way. Now take one example, like move A, comma, hash 25x. The 25x will be loaded inside the accumulator, then 65 will be loaded inside the register B. Now if I execute the instruction mul AB, then what will be the result? The 16-bit address will be 0E99. So 0E99. So 99 means the lower byte will be stored inside the accumulator. So accumulator will be, the 99, the value will be available inside the accumulator, and 0E will be available in the B register. Okay, so it can handle the unsend 8-bit numbers only, but operand larger than the 8 bits, it will need some manipulation. It is possible, but you have to manipulate the data. So this is the division operation. You see, in case of 8085 microprocessor, we have subtracted the number again and again. But here the division operation is directly performed by 8051 microcontroller with the instruction div AB. Okay. So what is that? The numerator is in accumulator and denominator will be stored in register B. So register B is also associated with this particular instruction div AB. Then after execution of this instruction, the quotient will be available inside the accumulator and the remainder will be available inside the B register. So CY means carry is always 0, and if B is not equal to 0, means the denominator is not equal to 0, then overflow flag from the program status bar will be equal to 0. And if b is equal to 0, then what will happen? It will indicate an error. Why? Reflecting the overflow flag as your logic 1. Okay. So let us check this example. Move a comma 95. So 95 will be loaded inside the accumulator. Then 10 will be, 10 will be loaded inside the register B. Then, but after execution of this instruction B, then 10 means actually it is represented in the decimal number. So a will be equal to 09, which is nothing but a question. But 10 into 9 equal to 90. So remainder will be 5. Then 5 will be stored inside the register B. Okay. So it is represented in the decimal number system. So let us check that what will be actually the decimal number of this hexadecimal number. Okay, so we have to divide it by 10 repeatedly. So 0 FD divided by 0A. So what will be the value? That 19, then remainder will be 3. So this is the low byte. After that 19 will be again divided by 0A. Then 2 will be the result, and 2 will be the quotient, and remainder will be 5. So it is the middle digit. Okay, and after that, so 2 is remaining, so it is with the high digit. So if the hex, which is nothing but equivalent to the decimal number 2. Now let us check the logic and compare instructions. First of all, we shall check the AND operation. So the common syntax is that ANL destination byte comma source byte. Okay, so this instruction will perform a logical AND operation between the two operands and place the result in the destination. So destination is normally the accumulator. Okay, so it is implied that the destination should be your accumulator. The source operand can be a register, any kind of the register, any kind of the immediate data, or the data that is stored inside the memory. Now let us check these instructions. Move a comma 35x. So 35 will be loaded inside the register inside the accumulator. After that, if we perform the operation ANL a comma 0fx, so the accumulator will be ANDed with the value, the immediate value 0fx. Okay, so you write the binary form of that hex number, that 35x, then 0fx. You see that the 0 will be ANDed with this 1. So ANL operation is performed to mark certain bits of the operands. Okay, so finally the result will be 05x. So 0, then 5. So we can mark these bits. Now come to the logically OR operation. Okay, so here the instruction that is used to indicate that it is the logical operation by writing ORL, then the destination byte, then the source byte. Okay, the destination is normally the accumulator, as in the case of the AND operation that we have already checked. The source operand can be in the register or the memory or the immediate data. So for the logical operation, either it be AND operation, OR operation, or the exclusive OR operation, the destination is normally placed inside the accumulator. Okay. So now let us check these instructions. Move a comma 04x. So 04 is the immediate data that is loaded inside the accumulator. After that, whenever we are executing the instruction while a comma 68x, so the accumulator, the value which is in the now present inside the accumulator, now it will be odd with the immediate data 68x. So this operation, the ORL operation, is performed to set certain bits of an operand to logic 1. Okay, so you can check this one by writing the binary form of the x in the hex value, that is 04x 68x. You see that these 1 and 1 makes this output is equal to 1 and 1. This one makes this output 1. So finally we are getting 63x. Now let us consider the exclusive OR operation. This instruction will perform the XOR operation on two operands and place the result inside the destination, and destination is normally the accumulator. And the source operand can be any register, or it may be the immediate value, or it may be stored inside the memory location. Okay, so from these two instructions we shall find what is the operation of the XORL, that is the XORL destination byte comma source byte. So move the value 54x inside the accumulator. After that, whenever we are just performing the instruction XORL a comma 78x, then 78x will be exclusive OR with the value that is previously stored inside the accumulator. So this instruction is used to toggle certain bits of the operand. Okay, now let us consider that 45x. This is one good example you can consider, so that I can clear the accumulator in this way. 4 5 hex and 4 5 hex. If I exclusive OR with the same value, then I shall get these, all the bits will be equal to 0. So in this way I can clear the accumulator. This is the complement of the accumulator instructions. Okay, so this is the ones complement we can find through this instruction. CPL A means complement A. So the register, I mean the accumulator is loaded with the value 5 5 hex first, and if we execute the instruction CPL A, then the 5 5 will be complemented and we shall get the result 0 A hex. Okay, to get the 2's complement, then first CPL A means one complement will invert the each and every bit. After that we shall add with 1, so that it will be 1 2's complement format. Now let us take the CJNE instruction, that is the compare instruction. It is the compare and the jump instruction, both are combined together. So the instruction, the format of the instruction is compare and jump not equal, the destination byte, the source byte, and comma the target address. So it will compare two operands, whether it is equal or not, and depending on that, it will take the decision where to jump. So it is specified in the relative address. The destination operand can be the accumulator or in one of the Rn register. Rn means n is equal to 0 to 7. So it may be either R0 or R1, R2 or R7. Up to R7 register will be accessed from the register bank of the 128 bytes of the RAM memory. Okay. The source operand can be in a register in memory or the immediate data. It will change only the carry flag. So mind it is basically the subtraction operation, but the value of the operand will not be changed, and only the carry flag will be changed. Okay, so carry flag will be changed, and it will indicate if the destination operand is larger or the smaller. So this is common format for using the CJNE instruction. If we write the instruction CJNE, then what will happen? It will check it will compare the value which is stored inside the destination or inside the source, and it will check, it will compare it whether it is greater than equal to the source value. The source is equal to the destination is greater than equal to source. At that time the carry flag will be equal to 0, and whenever the source is greater than the destination value, then carry flag will be equal to 1. So depending on that, I shall first execute the instruction. Whenever it will execute the instruction, then it will jump to the relative address not equal. Okay, if it is not equal, then it will jump to this location. After that, I shall check whether it is greater than or less than. Okay, so carry flag is always checked for the cases of the greater or the lesser of the value. Okay, but only after it will be determined that whenever it is executing the instruction, it is finding that it is not equal, then the carry flag will be checked whether it is greater than or it is the less than number. So instruction any register can be compared. So not necessarily that the accumulator you have to use the accumulator, but any register can be compared. I mean any value of the register from R0 to R7 can be compared. Now we shall discuss about the rotate instruction. Okay, so it is also a very important instruction used by 8051 microcontroller. So first of all, I shall discuss about the rotating right and left. In rotate right instruction, the 8-bit data which is stored inside the accumulator are rotated right by 1 bit. Okay, so therefore from D0 to D7, if you consider D0 here and D7 number here, then the LSB, and first of all, after the execution of this instruction, the rotate instruction RR and then A, then what is the value stored inside the LSB bit that will now rotate and it will be placed inside the MSB bit, which was previously treated as your MSB bits, that will be shifted in the right hand side position. Okay, so let us take this example. Move A comma 36x. So 0 0 1 1, that is 3, that is 6. So after execution of RRA instruction, one RRA instruction, that then this LSB means 1 will be now placed, I mean this 0 will be now placed here, and it will be right shifted by 1. So it will be 1 0 1 1, so 1 0 1 1, and after another RRA instruction you can check it, then 1 by 1 bit will be shifted in the right hand side and it will be placed inside the accumulator from the left hand side. So this is the RRA means rotating right instruction. and in the rotating left instruction, but the process that we have already described for the rotate right instruction, it will be just in the opposite direction. The rotation will be in the opposite direction. Okay. So after execution of this program RLA, then 8-bit data which is stored inside the accumulator, then D7 to D0 means D0 bit will be now the D0 bit will be now shifted in the left hand side, and the MSB bit will be now transferred to the LSB bit. Okay. So let us take one example like move A, 7 to S. So it is the accumulator value before the instruction RLA. So whenever the instruction RLA is executed, then what will happen? You see that from the MSB bit means 1, when 0 will be now appearing in the LSB position, and it will be shifted, means all the bits will be shifted by 1. So it will be 1, 1, 1, then 0, and finally the 0 that will be placed in the left hand position, right hand position in the LSB position. Okay. So therefore, another instruction is executed like RLA, then it will be just shifted by 1, and the MSB will be placed in the LSB position 1 by 1. Now, if we want to execute the instruction RRCA, then what the program that we have executed for the instruction RRA, now it will be transferred through the carry, means it will execute in the same way but through the carry. So what is the data stored in the accumulator? Now it will, if RRCA instruction is executed, and what will happen? The LSB position bit will be now transferred to the carry, and what is the value that was stored in the carry, that is now placed inside the MSB position. So in this way, it will rotate the bit in the right hand side. The carry is involved in between this operation. Whenever we are just performing only the RRA operation, that is only the difference. Okay. Similarly, you can execute the instruction RLCA, where the RLCA means the rotate accumulator left through carry. So here it is also same way that it is performing the rotation, like rotate left. RLA means rotate the bit of the accumulator in the left hand position, but it will go through this carry. So MSB bit will go to the carry bit, and carry bit will now be pushed inside the LSB position. Okay. So in this way it will rotate, and it will rotate the bit of the accumulator 1 by 1 through the carry. Now another instruction is that swap instruction. The swap instruction is executed, the instruction is executed on accumulator only. So we can write the instruction swap A. Then after execution of this instruction, the D3 to D0 will be placed in the higher enable, and the lower enable we shall find the bit D7 to D4. So it is interchanging the position only, exchanging their position only. So this is the summary of my discussion, that is the assembly language programming technique has been described over here, considering the different arithmetic and the logical instructions. And the most awaited part, which will be discussed in the next video lecture session, that is development of a simple prototype of variant using the 8051 microcontroller. So that will be discussed in the next lecture session. So to get notification of the next lesson, kindly share, kindly like, kindly subscribe to my channel. Thank you all. Thank you for watching my video.